A firewall is a network security device or software that monitors and controls incoming and outgoing network traffic based on predetermined security rules. Its primary function is to establish a barrier between a trusted internal network and untrusted external networks, such as the internet, to prevent unauthorized access and protect against cyber threats. Here's a simplified explanation of how a firewall works. Packet inspection. When data packets travel across a network, they pass through the firewall. The firewall examines each packet and compares it against a set of predefined rules, policies, or access control lists, ACLs. These rules dictate what types of traffic are allowed or denied based on various criteria such as source and destination IP addresses, port numbers, protocols, and packet contents. Stateful inspection. Many modern firewalls use stateful inspection to monitor the state of active connections. This means they keep track of the state of network connections, such as TCP handshakes, and only allow packets that belong to established or authorized connections to pass through. This helps prevent various types of attacks, such as spoofing or packet manipulation. Access control. Firewalls enforce access control policies to determine which traffic is permitted and which is blocked. For example, administrators can configure firewalls to allow inbound traffic to specific services, such as web servers or email servers, while blocking all other inbound traffic. Similarly, outbound traffic can be restricted to prevent unauthorized data exfiltration or communication with malicious servers. Logging and monitoring. Firewalls often include logging and monitoring capabilities to record details about network traffic, such as the source and destination addresses, ports, protocols, and actions taken allowed or denied. This information can be used for troubleshooting, compliance, and security analysis purposes. Network address translation, NAT. Some firewalls perform network address translation, NAT, which translates private IP addresses used within an internal network into public IP addresses when communicating with external networks. NAT helps conceal the internal network structure and conserve public IP addresses. Application layer filtering. Advanced firewalls may also perform deep packet inspection, DPI, or application layer filtering to analyze the content of packets at the application layer, layer 7 of the OSI model. This allows them to identify and block specific types of traffic based on application protocols such as HTTP, FTP, or DNS, and even inspect the content of encrypted connections, HTTPS. Overall, firewalls play a critical role in network security by controlling and monitoring network traffic to prevent unauthorized access, protect against cyber threats, and enforce security policies within an organization's network infrastructure.